So Unit 4 is going to be talking about ionic bonding at first. And the first thing that we're looking at here is just a review of ions. So we've got cations, and those are our positive ions. So sodium, if it's a cation, it has a +1 charge, or you can have +2, +3, or +4. Anions are going to be the negative ions. So those are going to be -1, -2, -3, -4 charges. The cations have lost electrons, that's why they are positive. They lost those electrons, and anions have gained those electrons. And remember that ions are going to form, especially with bonding, in order to create a full outer energy level, which is those 8 electrons, that octet rule. And one thing that's really important to look at is the fact that our positive and our negatives are going to attract, but the positive and positives will go away from each other. This is a very important chart, so you need to know these oxidation numbers. So +1 for group 1 is right here, so the groups are these top things. So group 1 has a +1, group 2 is +2, group 3 is +3, group 14 or group 13. Group 14 here is ±4, it can be either one. Group 15 here is -3, group 16 is -2, group 17 is -1, and group 18 elements do not bond. We might call those charges, but sometimes we also call those oxidation states. And those charges are going to tell us how it's going to bond. So for instance, fluorine is in this group, group 17, and it takes on a -1 charge because it's going to want to gain 1 extra electron in order to be happy. So with this bonding, the metals are on the left-hand side of the periodic table, and they are going to be the cations in these bonds. These metals are going to get rid of this last valence electron, or if it has maybe 2 or 3, it's going to want to get rid of those, and it's going to want to get rid of this entire outer energy level and go back to this 8 that you see on this second to last energy level. So it's going to get rid of that 1, and it's actually going to donate that electron to another atom, and that atom will have like 7 or maybe 6 valence electrons, and it's going to want to take that 1 and create 8 on that outer energy level. So the sodium in this example became a cation because it lost the electron. The chlorine became an anion because it gained the electron. And they have now opposite charges, so we have that +1 here and a -1 here, and because of those opposite charges, they're going to attract and form that ionic bond. So the attractive force is what causes the ionic bond to form. And when these ionic bonds are formed, the key is that the electron is transferred. So that's that big vocabulary word there, it's transferred. These ionic bonds are always made up of a metal and a non-metal. So the metal will come from the left-hand side of the periodic table. The non-metal will come from the right-hand side of the periodic table. And these ionic bonds, they're going to form these solid crystals at room temperature. So think table salt. They have really, really high melting temperatures because they're really good at keeping themselves together. So it's going to be hard to melt them. And then they also conduct electricity when you dissolve them in water. So when looking at this, you're going to have something from this side of the periodic table. So these are your metals. And then you're also going to have one thing from this side of the periodic table. Those are the non-metals. That ionic structure is going to look something like this, and this is actually a picture of table salt. And that's what it actually looks like because of the ionic bonds that are forming here. It makes this perfect cubic structure.